friends, let's have a look at today's daily challenge problem. Problem 1277. Count square submatrices with all ones. So this problem statement is very short, and however the problem is very interesting. So let's quickly look at the constraint. First, the matrix is not very large because the length, the number of rows, the number of columns are bounded above by 300, right? In other words, at most you have 90,000 cells. So this is the binary matrix. If you look at example 1, especially the explanation, you should have an idea how to do the counting, right? So each single one is a valid 1 by 1 matrix, and then count sets 2 matrices, count sets 3 matrices. So the problem here is to find a way to effectively counting the contributing submatrices. So here, if you look at the cell, the bottom right cell in the example 1, so this cell corresponding to a 3 by 3 matrix. This is the largest possible. So in this regard, here you can have 1 by 1 matrices, you can have 2 by 2 matrices, you can have 3 by 3 matrices, right? So maximum length is 3. So in this corner, it contributes 3 submatrices to the final result. So this will be our main point. So with that said, let's look at the main strategy. So here I'm going to use dynamic programming, right? Here I'm going to use tabulation. So I'm going to introduce m by n matrices. M is the number of rows and n is the number of columns of the original matrices. So here I'm using capital M to represent the matrices. So actually in writing the code, you can use m plus 1 by n plus 1 matrices. That introduces some convenience, but I want to share the thought process. So we are going to use m by n matrices. So here, the interpretation of DPRG will be the maximum square submatrices. For sure, with all ones, right? So with all ones. So we will denote this the set length, right? So then, ending at position ij, there are valid square submatrices with set length 1 by 1, 2 by 2, and dpij by dpij. In other words, from 1 to this number, the contribution is exactly this number itself, right? So we just need to sum all those numbers. So as you know, for dynamic programming, so one is two things are very important when you use tabulation. One is the element interpretation. Another is DP update rule, right? So if a cell ij is a 0, then it has no submatrices ending there, right? I mean square submatrices with all ones. So if the cell corresponding to a 1, then this is the set length at the position I plus 1, j plus 1. So it equals the mean of the left, up, and diagonal, the minimal set length plus 1. So here you can use example 1 to digest this one. If you look at position 2, 2, right? This is 2, 2, right? So if you look at 2, 1, so the largest square submatrix with all ones is 1 by 1. So if you look at 1 and 2, so this is 2 by 2. And then if you look at 1, 1, this is 1 by 1. So 1, 2, 1, the smaller is 1. So adding 1, this is 2. In other words, 2, 2 has largest submatrices with square matrices with all ones actually is size 2. So this cell will contribute 2 in the final result. So with that said, I guess writing the code should be rather straightforward. Now let me carry out this program. So I'm going to introduce m and n. So this is the number of rows and the number of columns, right? That's straightforward. I'm going to introduce first let's introduce a result variable. The final state is what we are going to return. So then we have 0 times n for a dummy index in range m, right? Let's first set the first row and the first column. So for j in range m, right? So we are looking at m 0g, right? If this number is 1, so then we set dp 0g to be 1, right? And also it contributes to the result by 1. Otherwise we don't care, right? So then for I in range, because for 0, 0 we have already set, let's write it from 1 to m. Then if mi 0 is 1, right? So we are going to set dpi 0 is 1. And also the result is incremented by 1. So otherwise we don't care. So this is the first row and the first column. So now let's just write down the dp update rule. So here for I in range, so 1 to m. So for j in range 1 to m, right? So then we just consider the position that is equals 1. So if it were 0, we don't need to consider. So the dpij. So we are going to consider the 3 positions. First is the left. So I'm going to write same row but j minus 1. Because here our I and the j are both starting at least from 1. So j minus 1 is meaningful, right? Also I minus 1 and j, this is the above. And then the diagonal top left, so it's I minus 1 and j minus 1. Then the minimal of those 3, then plus 1, right? So once we set this mij, right, dpij, so we can do result equals increment by dpij, right? And then we just need to return the final state of this result variable. So we can do a quick test. It passes the 2 test cases. So now you can submit that. Yeah, it passes all the cases. So now I can actually make 2 comments. First, here we do this, but we can make this instead, right? Because if mij is 0, so we don't need to consider an increment. So in other words, for this problem, the effect will be the same. You put a result, this line here or this line, the same level as the if. Let me submit again. But it's much faster in some sense, because slightly less operations. So if you want to understand the finer details, you can do this. You can print out this dp, right? So this gives you the contributions of each position. For example, this first row, each of the ones contribute 1, 1, 1, and this one contributes 1, right? So then this one contributes 1, this contributes 2 because it corresponds to 2, and this one and this one. Similarly here, 2. So this will be 1, this will be 2, this will be 3, right? So you add all this number together, you get 3 plus, this is 6, right? Plus 6, that's 9. 9 plus 6, that is 15. Similarly, you can look at example 2. So the summation of this matrix is 2 plus 2 plus 3, that is 7. So with that said, I guess that's basically about it for the current problem. Because here, the main point is to understand this dp update rule. Once you realize this relation, then writing out the solution is sort of straightforward. So you can design the format. For example, you can just use a 2 for loop, include the first 2 for loops inside here, right? But I'm writing like this format is to reveal the full raw sort process. So thank you for watching.